Reports on the topic is offered for your attention development of recommendation for improving the radiation monitoring system of Ukraine. Nowadays, many institutions and organizations worldwide use hazardous radiation technologies and sources of ionizing radiation in their activities. About 10,000 enterprises in Ukraine as of the end of 2021 were operating. Such objects include nuclear power plants, NPP, research reactors, specialized plants for processing and storing radioactive waste, enterprises extracting and processing uranium ores, and medical facilities using radioisotopes. All these objects are objects of increased danger because emergencies related to their activities can lead to highly complex consequences for the present and future generation due to uncontrolled accident and controlled terrorist act release of a significant number of radioactive substances into the environment. Therefore, one of the most critical components of the country's national security is the provision of nuclear and radiation safety. The legal act to regulate science publication information and resources were analyzed as the research the functionality of radiation monitoring networks. The result of analyzing showed that the problem outlined by us was considering and describing in the false direction. First, construction of environmental monitoring networks, developing equipment for radiation monitoring networks, developing software for analysis and visualization monitoring data, using monitoring data for solving management by the radioactively contaminated territory. Therefore, issues of ensuring nuclear and radiation security are looked up for worldwide. And the aim is to determine the main advantages and disadvantages of radiation monitoring networks and to provide a recommendation for the improve for Ukraine. Today, radiation monitoring in Ukraine is carried out by various entities like Energy Atoms, the State Agency of Ukraine, and Exclusions on Management, the State Special Agency, the National Academy of Science, and the Ukrohydromet Center, and the State Service of Ukraine for Emergency Situation. The system provides only sectoral observation of the radiation environment. All state information about radioactivity is open to the public source. Integrated network of radiation monitoring of the environment you can see in Feature 1 and 2. You can find out with the help of the map, the radiation levels, the location of the measurement point, and who provided the information. Then a nationwide radar system was generated to observe environmental radiation pollution levels. System radar has tracked radiation levels from testing nuclear weapon and nuclear reactors accident in Chernobyl and NPP Ukraine and Fukushima and NPP Japan. During a radiological incident, government officials use radar data to help make science-based decisions about protecting the population. Radar has 140 stationary air monitors that run 24 hours a day during the week and collect data near real-time gamma radiation measurement. Feature 3 shows radar static air monitoring location and precipitation and drinking water sampling locations that report data in 2020. On the national level, monitoring the dust equivalent rate is carried out on all territories of France. You can see in Feature 6, laboratory in the Institute of Radio Protection this red nuclear. The ultimate detectors represent proportional counter manufactured by BATT technology. You can see in Feature 5. The monitoring system operates in real time and includes redundancy recovery plan and an agreed service commitment from the network operating. Monitoring of the public radiation dose, specific dosimetry, is carried out using about 100 dosimeter. The Swedish Radiation Safety Authority, ASME, managed two telemetric networks for monitoring external gamma dose rates. Nationwide network consisting of 28 monitoring stations. You can see in Feature 8, in a network comprised of 30 monitoring stations near nuclear power plants. You can see in Feature 7. The monitoring station operate autonomously and transmit data continuously to the network service SSME. SSME manages the monitoring station via special software and ensures supporting operations through collaboration with the administration in the NPP. The German nationwide monitoring networks includes 1,800 stationary probes equally distributed over the German territory with a typical distance of 20 kilometers between them. You can see in Figure 9. Their density is increased in the 25-kilometer emergency planning zone around NPP. These additional probes are installed and operated by complementary networks from federal state. Data are exchanged between das Bandsmitführer Trashluss, BFC, and the local government carried out a bilateral agreement. In the emergency regime, data from all stations can be accessed almost in real time, enabling the population information to be efficient and prompt. The country operates 25 nuclear power reactors, a nuclear research reactor, nuclear fuel fabrication facilities, and radioactive waste disposal facility. Korean Institute of Nuclear Safety, KINC, is the only atomic safety regulatory aspect organization that protects the public and the environment from the harmful effect of radiation. KINC, on behalf of the Korean government, conducted radiation monitoring around nuclear facilities and analyzed the relevant samples. Furthermore, local government around nuclear facility have operated the radiation monitoring system. National Emergency Operations Center has its radioactivity monitoring network, NADA. It consists of 76 stations placed on the meteorological station, Meteo Swiss, in all territory of Switzerland. You can see in Figure 11. That transmitted the measured value of at 10 minutes in interval to the National Emergency Operations Center. Mainland China is building and exploiting 56 nuclear power units as of 31st March 2022. 38 of them are operating units. All data about NPP environmental radiation monitoring can be received at the website, and also you can see in Figure 12. To analyze and compare the nationwide monitoring system of different countries, the criteria for displaying data on the electron map about the state of radiation pollution were determined. The author of the publication attribute to such criteria you can see in Table 1. First, interface in national and English language. Second, meteorological data. Third, the speed of updating the display of radiation monitoring data on the map. First, number of radiation monitoring network posts. Fifth, coverage density of the radiation monitoring network. Sixth, availability of mobile radiation monitoring stations. Seventh, coordinates of location of stationary posts. Eighth, coordinate of location of radiation hazardous facilities. Ninth, availability and coordinates of radioactive monitoring station of water bodies. 10th, availability of these stationary monitoring stations for atmospheric air pollution by chemical substance and dust of various fraction. And 11th, ability to export monitoring data for a certain period to a separate file for independent analysis. We also analyzed the availability of various reports on the functioning of the radiation monitoring networks of the above-mentioned countries which were found in public access. Accordingly, criteria were developed for the following reports. You can see in Table 2. First, availability of materials at English. Second, frequency of updating the report of the function of the radiation monitoring networks in the country. Third, the year of publication of the last general report on the functioning of the radiation monitoring networks in the country. And first, availability of information about radiation pollution from radiation hazardous object. To improve the radiation monitoring system of Ukraine, the author suggests the following. To improve and optimize the notification system for receiving daily information, increase the coverage area of monitoring network posts to obtain more accurate information about radiation pollution, increase the number of mobile surveillance posts. The electron map which displays the state of radiation pollution indicates the coordinates of the location of radiation hazardous object. Make it possible to export monitoring data for a certain period into a separate file for independent analysis. Implemented an interface of maps and reports in English to provide information to the wide masses. To update quarterly publicly available reports on the radiation status of the territory of Ukraine, including on the website of related international organization, and to prove information on radiation pollution from radiation hazardous object. One of the main aspects of nuclear and radiation safety is radiation monitoring in the territories where hazardous radiation facilities are located, which various legal acts regulate. The effective functioning of radiation monitoring networks is an essential task for every country of the health of personnel working at hazardous radiation facilities and the population living in contaminated areas. A critical analysis of the function of nationwide monitoring system of various countries of the world shows that this system have difference in the organization. And the criteria for displaying data on the electronic map about the state of radiation pollution and the criteria for a report on the function of nationwide radiation monitoring networks, which showed the advantages and disadvantages of such system were defined. Thank you for your attention.